Now with the same example, let's see what is CDF, cumulative distribution function. We saw this with the discrete random variable, and it is the same concept actually. So it answers to the same question. The probability of x is less or equal than a specific value, a small x here. So what it does exactly, actually, it calculates the total accumulated probability from the very beginning up until a specific cutoff point x. So instead of we know our function is defined from 0 to 2. Here we calculate it from 0 to a specific value, let's call it x. That's the only thing we do. So how to find the derivative of our function from 0 or from anything, maybe from a to x, actually from the beginning, because this a can be minus infinity, can be 0, can be a number, can be any number actually, so it can take any value. So it depends on where fx is defined. So in our example it's from 0 to x because it's defined from 0 to 2. Now what is the antiderivative of this? We have it, it's x minus 1 over 4x squared, and let's find from 0 to x. We replace x by x, we keep it as it is, minus we replace x by 0, so it's 0, it's 0, we get 0, minus 0. So this is our result. Now how can we write this? When our fx equals this value, it is true only when our x, where our fx is defined, which is from 0 to 2 here. Sorry, here it is 2. So from 0 to 2, because our fx, our function is defined from 0 to 2. So this is applicable only when x is from 0 to 2. Now let's check the other sides, like above 2 and below 0. What happens exactly? So for the values below 0, it is our fx is 0. For the values above 2, from 2 and above, it is 1. Our fx is 1. Now let's see why anything that is above 2 gives a probability of 1 for fx. Okay, so first let's take an example for a number x greater than 2. Let's say 3. This is x equals 3. So what is f3? We know that fx answer this question, px below or less or equals our x here, so 3 here. So what is the probability that x is less or equals 3? We know that it cannot exceed 2. We know it's not possible to exceed 2. So the probability that it takes less than 3 hours here is 100%. So anything above the limit here, which is 2, means it's 100%. The probability that it takes less than 10 hours is 100%, because I know from the beginning that it cannot exceed 2 hours. And the same thing for this. Why anything below 0 is 0? Because it's like I tell you, what is the probability that x is less or equal minus 1, for example? I know it's not possible, so it's 0. Px is less or equals minus 2. it's not possible, it cannot be negative. So this is why once we found this, we got x minus 1 over 4x squared. We need to write this as well, this, because this value is true only when our x is in its domain between 0 and 2, and the rest, so outside the domain, above the upper limit, it is 1, under the lower limit, it is 0. So let's take an example. If I ask you what is the probability that this technician takes less than 1 hour, so we want to find px less or equals 1, it's f1. It's like we are looking for f1. We 1 here is within the range between 0 and 2. We replace it here, we replace it here, we replace 1 here or here, and we get 1 minus 1 over 4 times 1, which is 1 over 4. We get the 0.75. And what does this mean? It means that this technician, the probability that this technician finished the task under 1 hour is 75%. Now let's see how to find the expected value and the variance. So let's start with the expected value. In discrete, we use in discrete random variable, we used Ex equals the sum of xc times p, which is the PMF, or the probability mass function. In our continuous version, so the same idea, so our expected value is, so instead of the sum of, we use the integral, we keep our x, and also instead of PMF we use our PDF, which is the density function. So the same thing. So here our expected value is the integral from within the domain of our function. Here in the same example, it's from 0 to 2. X, we multiply our x with the function itself, which is 1 minus x over 2. So we get this, so we want to find the integral of x minus x times 1 is x times x over 2 is x squared over 2. We do the math as we did with the here, the derivative here, we apply this, so we get the antiderivative, or the primitive of this, is actually 1 over 2x squared for this, minus 1 over 6 x power 3. So this is the primitive. Now we replace x by 2 here. We get for this part it is 2, and for this part, when we replace x by 2, we get 8 over 6, minus we replace x by 0, we get 0. So 2 minus 8 over 6 is 4 over 6, or 2 over 3. So this is the result, and this is the expected value. And what does expected value tell us? It means that the expected waiting time, so that this technician will fix this laptop, is 0.6667 hours, or 2 over 3 hours. Now let's see how to find the variance. also like the diskette, we say the variance is e of x squared minus ex squared. So we apply the same thing here. Instead of multiplying our function by x, we multiply it by x squared to find this, to find ex squared. Then we get this x squared times 1, we get x squared times x over 2 is x power 3 divided by 2. We find the antiderivative of this, which is 1 over 3x cubic minus 1 over 8 x power 4. We replace our x here by 2. When I replace x here by 2, it gives 8 over 3 minus, when I replace x here by 2, it gives 6 over 3, and when I replace x by 0 for both, it gives 0 minus 0. In the end we get 2 over 3. So our e of x squared is 2 over 3, and we know that the variance is e of x squared, which is 2 over 3, minus ex squared. Ex, we found it, it's 2 over 3. We square it, we got this one is 4 over 9. So we convert this from 2 over 3 to 6 over 9. So the result is 2 over 9. This is the variance. We can find the standard deviation, which is the square root of the variance, and we got 0.47. And what does this 0.47 means actually? So here we said I expect that the waiting time for the technician to finish his task is 0.6667 hours. So with this variance, or this standard deviation of 47, I can say that the expected value is 0.6667 with a margin of 0.47. So this is all about the CDF, the expected value, and the variance for continuous random variable. Thank you for watching, and see you in the next video.